Hey class, I want to do a few more examples of solving absolute value equations and inequalities. Mainly because I think this is probably one of the harder sections of especially the first chapter. And we did a few basic examples in class time this week, and we really focused on the concept and why it makes sense, but I just wanted to do a little bit more of this step-by-step practice for those of you who kind of prefer to solve them that way. So when it comes to an absolute value equation, remember that the first step is we want to always get the absolute value by itself on one side of the equation first, because if we don't get it by itself, it's hard to know what will happen, because the absolute value is what is kind of like the key algebraic expression in the problem. So like in this particular case, we could add 5 to both sides because that's not within the absolute value. And also, as a reminder, you're not allowed to work within the absolute value. Like this plus 5 and minus 5 will not combine because one is within an absolute value. And there is no way to simplify this, and you can't really deal with it as you would a normal set of numbers or algebraic expressions. But in this particular case, I could add 5 to both sides because that is not inside the absolute value. And that would leave me with absolute value of negative 6x plus 5 is equal to 23. And then at this stage, this is when we have to apply what I call the equivalencies, but basically it's a way to get rid of the absolute value in an equation, because as I said in class time, you're not allowed to simply cancel it or make it positive. Those sorts of things don't work. But what we can do is know that, well, we want to make sure that this entire expression is equal to 23 or negative 23, right? Because if the inside adds up to negative 23, then the whole absolute value will make 23, whether it's positive or negative. So that's the whole thing where we could split it as a two-part equation, negative 6x plus 5 is equal to 23, or negative 6x plus 5 is equal to negative 23. And remember that the idea here is, well, the first part is just the exact same equation, drop the absolute value. And the easy way to remember it is the second part is the same thing, but you're changing it to a negative. Because absolute values, the inside could be either positive or negative, and it will work in either case. And now we can just solve each individual equation, and that should give us our answers here. So from here, now I'm allowed to subtract the 5 to the other side, and that would leave me with 18. And I could then divide by negative 6, which would leave me with x is equal to negative 3. And then in the secondary equation, same exact steps, because right, it's the same algebraic expression. I can subtract 5 to the other side. Here I'm going to get a different number though, because negative 23 minus 5 would be negative 28. And then I could divide by negative 6 from 28, which would become positive, because negative over negative. And I could even reduce this by a factor of 2 down to 14 thirds. And you might wonder, well, should I answer as a decimal or as a fraction, or some other format? Typically, I don't really care. I'm not too particular. But what you do want to be careful about is when you're in my math lab, pay attention to the format it asks for, because it might ask for a fraction, it might ask for a decimal, rounded, whatever. And at the end of the day, I'm not too particular. But basically there we have it. We get our two separate solutions. And again, that is separated by or, and it's not and, recall, because and means it has to satisfy both simultaneously. And we want to indicate that it could be either this or this as our acceptable answers. And you could write it as a set by saying, well, x is an element of the set of numbers negative 3 and 14 thirds, by using set notation. But again, I'm not too particular about how we answer it. It doesn't really matter to me. But there's a number of ways we can express this. But we have two specific answers. We don't want to put it in interval notation. That's what I wanted to mention here, because in an equation, we typically have singular answers or individual numbers, not full ranges. Whereas within an inequality, we get full ranges, like say from 5 to 12 or whatever. And also when applying the same ideas towards inequalities, what I actually wanted to do is solve the same exact equation, but let's say we're an inequality. What would be the difference in the answer? And actually why I bring this up is because what you'll see in the answers, it's going to involve the same exact two numbers, because how we actually solve it is the same. What's just going to change is the interval. And the short story to what our answer is going to look like with an interval is it's either going to be in between these two numbers, like sandwiched in the middle, or it's going to be outside of them. What I like to call the two tails of the interval or of the number line. And we'll kind of look at all that. But let's say we're applying this to an inequality where it were less than 18 instead of equal to 18. So we're going to take the exact same equation and just change it to an inequality, because at the end of the day, the difference between an equation and an inequality, there really is not a difference. There's just some very little minute details in terms of what our answer is going to look like, but the strategies and the patterns and everything else involved are very rarely any different. So, in the same way, I could solve this by, I still want to isolate the absolute value expression first and get that all by itself. So I get the absolute value of negative 6x plus 5 is less than 23. And then again, I would apply the equivalency. So the one thing I want to reiterate is that it's different for inequalities, and it's different depending on whether the absolute value is less than something or greater than something. When it's less than something, it always creates what I call an inequality sandwich. And when it's greater than something, it always splits as an OR. But it works in very much the same way that the equation does. So if you kind of were, if this made sense where I split into two using plus or minus, it's going to be the same way for an inequality. But when it's less than, there's always the shortcut where I can just sandwich it in between plus or minus 23. So in the same way, the equation's going to remain the same. Part of it, because when you drop the absolute value, that's still technically partially true, because the inside could be positive, and in that case, this statement will still make sense. But in the case when it is negative, that's when this will not hold up. So this is not entirely correct anymore, but it's part of the story. But basically, as long as this ends up being less than 23 or greater than negative 23, and again, and technically it's and greater than negative 23, as I discussed with compound inequalities, it has to satisfy both, which is an and. If you're trying to split it into two separate statements. But I prefer to not split it just because I think it's easier to solve it this way. But I totally lost my train of thought here. But basically, I apply the equivalency, which says to put your u, which is the inside of the absolute value, in between plus or minus c, where c is just whatever is on the other side, which was 23 here, and u is going to be negative 6x plus 5. So u goes in the middle, 23 minus 23. And now I'm going to solve it as we did before. So I could subtract 5 from all three sides. Let me draw a little line here to get x term by itself, which would leave me with negative 28 less than negative 6x less than 18. And I could divide all three sides by negative 6 finally. But you'll notice that this math is all very familiar because it is actually the same thing that we just did. And that would leave me with 14 thirds positive. Again, when we're dividing or multiplying by a negative, we have to change the directions of the inequality, as we talked about in a previous video, and is greater than negative 3. Or, a more common way of writing it is from smallest to largest. Instead, negative 3 is less than x is less than 14 thirds, which means the same thing. Or again, I could write this using interval notation as it's between negative 3 and 14 thirds as the final answer we're looking for, and even graph it to try to understand it as well. And again, technically it's a compound inequality involving and, but I think it's just easier to skip that and just write it using the x's stuck in between it. And there we have it. And notice the answer, it's the same numbers, but it's written differently, because here it was a specific two answers that worked for an equation, right? Because this is equal to this. And again, we could substitute it back into the equation to make sure it makes sense. With an inequality, we have a lot of different numbers that make sense, and it's always in between the two values. And this is something else you can take away. When your absolute value equation is less than something, it's always going to be in between them. Well, that's unless the direction changes, because sometimes, remember, the direction changes in the inequality, but once you've isolated the absolute value all by itself, if it's less than it in that state, then it will always be boxed in between the two answers you would have gotten for the equation. And if it's greater than, instead, it's the same exact answer, but it's entirely opposite. So if we were, let's go ahead and set that up. If we have that equation, but greater than negative 6x plus 5 minus 5, let's just say this were greater than, well, we would do the same thing. We'd add 5 to the other side, and that would leave us with absolute value negative 6x plus 5 is greater than 23, I mean. And then I would just apply a different equivalency. So when we have an algebraic, the absolute value of something is greater than c is equivalent to this or this. So just as another word of caution here, you can't do the sandwich when it's greater than, because the sandwich notation only works with and. It doesn't work with or ever. That it can't work the way we write it, and there's no other shorthand, unfortunately. Well, there are certain shorthands, but none that are common. Anyways, but again, it works exactly the same way as the equation did, where I want to take my inequality and split it into two. The first is going to be exactly the same with a dropped absolute value symbols, because again, it will work if it's positive. If the whole inside was positive, there's nothing going to be, it's just going to be fine as it were. But the thing is, if the inside were negative, it's going to become backwards. And again, you always have something is equal to plus or minus. So basically that was the positive case. And the negative case, we have to just do that. We have to change the right-hand sign to a negative. Again, because paying attention to it, it says it's either u is greater than c or u is less than negative c. And notice that I like to do the positive, the greater than c first, which is not the same as the notes, but it's just because it's, the way I like to think about it is, well, take the same equation and what am I doing? I'm doing kind of the same thing every time. And then in the other case, well, negative 6x plus 5, it's going to be, instead of being greater than negative 23, it's going to be less than negative 23. And again, it changes signs, and that changes the direction of the inequality. And we discussed kind of why that's true in class time and why that makes sense. But I'm trying to focus on the steps for this one and not get too carried away. Anyways, and again, the solution solving process will be the same. I subtract 5 and divide by negative 6, which would give me x is less than negative 3. And over here, subtract 5 would be negative 28 and divide by negative 6. Again, these numbers are familiar because we already did all this math. And when I divide by negative, I need to change the direction of the inequality. So what I end up with is x is less than negative 3, or, which again is the union, x is greater than 14/3. And since these are disjointed intervals, these are going to, I just can put the union sign in between them here. So this would be all values smaller than negative 3, or all values greater than 14/3. And that will be my answer. And there's no way of rewriting that because those are just completely separate. Again, you can graph all these and so forth, but a lot of times you can skip the graphs and the other notations, just go right into interval notation. But the point of graphing and practicing with those number lines is so that it's easier to understand the notation, and we can kind of have a visualization of the sets of numbers and what is in there. Without practice, it's hard to do that. And there's a lot of things we do in math. We graph it so that we can have this visualization, and it's more of something to do in our head rather than draw and write, because it can be a little tedious to graph things over and over again. But those graphs can help us do a lot more elaborate things in our head. Anyways, that's it for this one. We'll start chapter 2 in the next module.